Hello, this is lesson 3.3. We're going to be talking about interpreting the unit rate and slope. So let's get started. Okay, the objectives for today are going to be number one, I can use slopes to compare unit rates. And number two, I can graph proportional relationships. So this is from EE5 standard, graph proportional relationships, interpreting the unit rate as the slope of the graph, compared two different proportional relationships represented in different ways. So we're going to cover all of that today. I'm going to minimize myself. And here's my math meme. Well, it's a good thing I'm wearing my slope sitting suit. There's her slope. Ha! We should all have one of those suits, especially for the next few units. Okay, let's move on. Unit rates and slope. Slope is lots of things we're going to talk about now. It's a constant rate of change. Slope is the change in y divided by the change in x. Slope is rise over run on a graph. Unit rate. Unit rate is the rate in which the second quantity in a comparison is equal to 1 unit. The unit rate is the number on the graph where x is going to equal 1. The unit rate is the output when the input is 1. So it's the y value when the input x is at 1. The unit rate is the dependent variable when the independent variable is 1. Again, independent variable is x, dependent variable is y. This would be good to go back through and review so you make sure you understand this. Let's see how slope and unit rate compare. A storm is raging on Misty Mountain. The graph shows the constant rate of change of the snow level on the mountain. Notice how it's a constant rate of change. Okay, here's our graph. Notice how I have put time as my independent variable. So as time increases, this is a direct relationship. The snowfall in inches also increases. So the snow is dependent on how much time has gone by. That's your dependent variable, y. So find the slope of the graph using 2 points on the graph. So I've got 4 points there for you. Remember that slope is the constant rate of change. It's how y changes in relation to x. It's also known as the constant of proportionality, which is what we talked about in the first couple of lessons. So there's our formula. We have to memorize that. Slope is equal to y2 minus y1 over x2 minus x1. Notice that y2 can be selected as any one of the points, and y1 can be the other point. Doesn't matter which one you select as y1 and y2, as long as you keep the x2 below the y2 and the x1 below the y1. It'll all become the same slope no matter what points you choose. Okay, so we are going to pick point 1, 2. Notice how these go up by ones. Always look at your graph scale to know what you're talking about because they can change. So this is 1, 2, 3, 4, 5. So every tick mark or every line is a 1 unit. And going up, the same thing. Every line is 1 unit. So this is on the 1 and then 2. So that's point 1, 2. Picking another point, 5, 10. So that goes up from the 5 line. Let me actually use my spotlight here. That goes up from the 5 line and over to the 10. So 5, 10. X is the first number listed and then Y number is second. So now we have to pick our Y2s and our Y1s. So I picked this as my Y2 and this as my X2. This as my Y1 and this as my X1. Should really use red, it's easier to see. So I plug in my formula, I plug in 10 minus 2, And then below it, I have to make sure the 5 is below the 10 because they're partners. 5 minus 1. And then I just solve the math. 10 minus 2 is 8. Oof, look at me. And 5 minus 1 is 4. 8 over 4 can be reduced to 2. 8 divided by 4 is equal to 2. What does that mean? The slope is 2. What is the unit rate of snowfall? The unit rate is where x equals 1. So we go on the graph and we find where x is 1 and we go up and we see, well, where is it hitting the graph? Well, it's hitting it at 2. So the unit rate is 2. The unit rate is the y value where x equals 1 on the graph. So it's 2. And we know that the slope is 2. The unit rate and the slope are the same thing. 2 feet of snow falls in 1 hour. That is the unit rate. Notice that the slope and unit rate are the same, exactly. And the graph for this proportional relationship is y equals 2x. Why is that? Because we use our famous y equals mx. And pretty soon, and I think you may have already been getting this a little bit in your Khan Academy or even this week, you're going to get a y mx plus b equation. So you're going to get this one is the y-intercept. We'll be talking about that in our next module, but you might get some of that in Khan Academy this week. So this is your slope. 2 is your m, your slope. And x and y just stay in there because whatever input value you put for x, you're going to yield an output value for y. So if I put in 2 hours, I'll get 2 times 2 or 4 inches of snow. If I put in 10 hours, I get 2 times 10 is 20 inches of snow. Okay. That's why the formula is great. Okay, you get to try this. You can either pause the video and do the quiz questions for your turn number 1 first and then come back. That's how I would suggest doing it. But sometimes you might want to just watch the whole video and then try it. So it's up to you. I'm going to continue on then. Okay, this one is graphing proportional relationships. So every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation. Well, the biggest task right now is to figure out what x is and what y is. Which one is x and which one is y? We have a choice of seconds or time. I'll put time there instead of seconds. Time in seconds. And we have a choice of cubic feet of water. Which one do you think is the dependent and which is the independent? Remember, the independent is the x. It doesn't depend on anything else. And then the dependent is the y. Right. Time doesn't depend on anything. It just keeps happening, doesn't it? Just goes by. Nothing stops it. Keeps going day after day after day. So that is your independent variable. That is your x. Cubic feet of water then would be your dependent variable. As time increases, more cubic feet of water will pass over the dam. Can we clear that? So we're going to make a table. So we're going to say, like we did, let x equal the time and let y equal the volume of water. Here's our table. X is equal to time, y is equal to volume of water. On tables, they always put the y value on the bottom, the x value on the top. But don't get that confused with when you find the slope, y goes on top and x goes on the bottom, right? Okay, so what I did is I put in 3 seconds and I knew that 4 cubic feet of water would pass. And then I said, well, then in 6 seconds, 8 cubic feet of water would pass because this goes up by 4s every time. And then if this goes up every 3 seconds, the next 3 seconds is 9. The volume is going to go up by 4. Then it's going to go another 3 seconds up. The volume's going to go up by 4. Another 3 seconds goes by and the volume goes up by 4 more. So that's how I got my table. And then the second step is to draw a graph. Well, my x is going to go on the bottom. Now that I know it's time, I'm going to label it as time. And I know that my y is volume in cubic feet. And then I got to look and decide on a scale for my graph. And I noticed that I did 10, 20, 30. So what does each line represent? Doesn't look like it represents 1 unit, does it? No, this represents 2, 4, 6, 8, and there's 10, 12, 14, 16, 18, 20, etc. It goes up by 2s. What about the Y value? How does that go up? The same way, right? 2, 4, 6, 8, 10, etc. So every line is 2 units. Okay, now that I notice that, I am going to plot the points from my table. So I'm going to plot point 3, 4. Well, 3, my little spotlight again. Actually, I'm going to use this arrow. 3 here is in between 2 and 4. So it's kind of right in the middle. And then the Y value is 4. So that's right on the, get rid of that there. I don't know how to clear that. There. So that here is the 4, because 2, 4. So that's 0.34. Then I did 0.68, 2, 4, 6, and I go up, and there's 8. And then I have 9, 12. 9 is in between 8 and 10. 9, and this is 12. 12, 16. Remember, they go up by 2s. 12, 12, 14, 16. And then 15, 20. And then I draw my line to connect my dots. This is a proportional relationship. Notice it goes to the point 0, 0. Step 3 is to find the slope. I'm picking 2 points, so I picked 0.68 and I picked 0.1216. I could easily pick any point, right, that I wanted on those points that I graphed. Then I use my formula. Slope is y2 minus y1 over x2 minus x1, or rise over run. You have 2 options when you have a graph of how you find the slope. I will show you both. Okay, this is the formula way. I have y2 being 16. And it's always good to write these by the numbers so you don't get messed up. This is going to end up being my y1. This will have to be my x2. And this has to be my x1. So I have 16, spotlight here, 16 minus 8 and 12 minus 6. Again, notice how I have the 16 and the 12 paired, one above the other because they're partners, and the 8 and the 6 paired. Now I just do the math. 16 minus 8 is 8, and 12 minus 6 is 6. Then I reduce. Divide top and bottom by 2, and I get 4/3 as my slope. Now let's see that on the graph. So I rise and I run. So this is my run, my horizontal. I've gone 6 units. Remember, every line is 2 units. So I've gone 2, 4, 6. Actually, I will draw that. So I went 2, 4, 6 units. Then I go up for my rise. How many units have I gone up? Well, I'm here. 2, 4, 6, 8. Okay, so that would be my rise. There's my 8. Notice how those are the same numbers I have down here. This is my X, my run, and this is my rise. Starting to make sense? Good. Okay, then I do rise over run. 8 on top, 6 on the bottom, and then I reduce. And that will give me 4/3. Notice how I got 4/3 here, and I got 4/3 there. So formula or graph, they both give you the same slope. What is the unit rate of this proportional relationship? What is the unit rate? So that's where x is 1. What is y going to equal? So here's 1. What is y? It's going to hit right here. What is that point? It's hard to tell from the graph, isn't it? That's why we find the slope, because it's where the slope is. I mean, the unit rate is what the slope is. So 4/3. So notice 4/3, 4/3. 4/3 is the unit rate and the slope. They are the same thing. 0.1 4/3 is on the graph. So where x equals 1, spotlight again here, 4/3 is the y value. What is 4/3? That's 1 1/3. So if we look at it, it probably does look like 1 1/3. If this is about 1 and we go over to here, remember each line is 2, so that's about 1 1/3. It's hard to tell that on a graph. That's why we have to calculate the slope. And the equation of the line is y equals 4/3 x. Whatever number of time we put in for x, it will yield a volume of cubic feet for y. So we would take 4/3 times, let's say 10. Let's say we put in 10. And I'm using blue here. I'm going to put in 10. So now I would multiply 10 times 4, 40, and I would divide by 3. And that would give me my volume in cubic feet. For sake of time, I'm not going to do that. I just wanted to show you how to do that. Okay, let's go on. Let's graph another proportional relationship. Thomas rides his bike, or maybe it's Thomas, I don't know, at a steady rate of 2 miles every 10 minutes. Graph the situation and find the unit rate. So I would encourage you to pause the video and do this on graph paper and then come back, watch the video and see if you got it right. So we have to figure out what x is, and we have to figure out what y is. Which one's dependent, which one's independent. Remember, dependent is the y and independent is the x. He bikes at a steady rate of 2 miles every 10 minutes. Well, we have minutes and we have miles. Notice that minutes don't depend on anything else. Again, that's time, and time just ticks by, not dependent on anything. So time will be equal to your x, and your miles, or distance, we might want to call it, will be equal to our y. That's dependent. So as time goes by, the miles are going to increase. That is a direct relationship, not an inverse. Inverse is a negative slope. Direct is a positive slope. Okay, step 1, make a table. X is time, y is distance. There's our table. So I put in 10. So every 10 minutes I went up 10, 20, 30, 40, 50. So for every 10 minutes, 2 miles goes by. So the first 10 minutes I have 2 miles. So I'm going to go 2 more, 2 more, 2 more, and 2 more. And then I'm going to plot or draw my graph and plot the points. So there's my graph. Again, time's on the bottom. Distance is on the y value going up. I have to look at my scale here. What did I have going on here, right? It's a little different. So you got to figure out what your scale is. So 10, and then it skips a line, and then it goes to 20, and it skips a line, and it goes to 30, skips a line, 40, skips a line, 50. Okay, so every line is 5 units. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, etc. Going up is a little different. It's 1, 2, 3, 4, 5. Every line is 1 unit. So now I know that, I can start plotting my points. So I'm going to plot 10, 2. There's 10, 2. 24, 36. Plot 4 or point 48. And plot 50, 10. And then I connect my dots. This is a proportional relationship. It goes through the point 0, 0. Okay, step 3, I'm going to find the slope. How do I find the slope? I have 2 methods when I have a graph. I can do y2 minus y1, or I can do x2 minus x1. And then I could do rise over run. So I'm picking 2 points, 10, 2 and 50, 10. I'm going to make those my formula points. You can pick any 2 points you want. Pick ones on where the lines meet, please. y2 minus y1. I think I'm probably going to pick this as my y2 and my x2. Why? Because then I don't have to deal with negatives. y1 and x1. And let's see what I did on my slide here. Yes, I did 10 minus 2 over 50 minus 10. Notice how I paired 10 and 50 together and 2 and 10 together. And let's do the math. 10 minus 2 is 8. 50 minus 10 is 40. I reduce that. that becomes divide top and bottom by 8, 1/5. So my slope is 1/5. Now I can also do that by doing rise over run. So there's my run. I count my units. Now remember, these units go up by 5. So it would be 5, 10, 15, 20, 25, 30, 35, 40. By the way, why did I stop? Why did I stop right here? Why did I stop here? Because I have to stop where it's going to connect to the line up here. Okay, so that's 40 units. And then my rise, we're going to count those individual units because remember the Y values go up by ones. 1, 2, 3, 4, 5, 6, 7, 8. Isn't that interesting? It's 8 for the rise and 40 for the run. That's exactly what we did over here. And notice that the formula is actually the same thing, isn't it? It's counting the rise and the run units. Okay, then we put rise over run, 40 over, or 8 over 40, reduce 1/5. That's the same thing. What is the unit rate of this proportional relationship? That's where x equals 1. Can we tell? Well, that's going to be pretty hard because 1 is way over here kind of, but we don't even know what that point is. So we have to think about what does unit rate mean? That's when the slope, that's the same as the slope. So we already know it's 1/5. So 1/5 miles per minute. That is our unit rate. So the point is 0.1 will hit the graph here at 4/3, which is pretty hard because our lines go up so small, but it'd be 4/3. Oh, not 4/3, 1/5. I forgot to change that number. I'm gonna say, what on earth? Okay, so that should be 1/5. I will cover that up just like that. There, 1/5. So when this point is 1, somewhere over here, this point over here, the Y value is 1/5. So it's pretty hard to tell from the graph, but that's why we do the math calculations. And then our equation, at least I got the equation right, y equals 1/5 x, because 1/5 is our m, that's our slope. Any number I plug in for x, I will get a y value of distance, right? So if I plug in 10 minutes, I will get 2 miles, right? If I plug in 20 minutes, I will get 4 miles, etc. Okay. Okay, you get to try this. See you back in a moment. Or maybe you're going to do it at the end. I don't know. Okay, let's continue. Using slope to compare unit rates. You can compare proportional relationships using tables, graphs, and equations. So you have 3 things: tables, graphs, and equations. So again, we can compare using, I want to underline this. We can do it using tables, we can compare using graphs, and we can use equations. And we are going to do all 3. So you can compare a table to a graph. You can compare an equation to a graph. You can compare an equation to a table. You could also compare equation to equation, right? Or graph to graph, or table to table. You can compare an equation to an equation, a graph to a graph, and a table to a table. Okay, so here we're going to start doing that. Okay, here's a graph. Let's take a look at it so we can understand what it is. What's it talking about? What's its scale? Well B pumping rate. So we have a graph of well B. So as time increases, the number of barrels of whatever, probably water, also increases. It's a direct relationship. So let's take a look at the problem. Here's a table. So the equation y equals 2.75x represents the rate in barrels per hour that oil is pumped from well A. Okay, we have a graph of well B. We don't have a graph of well A. What do we have? We have a equation, or an equation right here. Do we know what the unit rate is for well A? Of course we do. The unit rate is the slope right here. It's the number in front of x. It's the coefficient in front of x. It's the m. 2.75 is our rate. Okay, the graph represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? So we don't know the rate yet of well B. We have to find the slope of that graph. So step 1 is make a table for well A. So that's pretty easy. We've got a formula here. So if I plug in 1 hour of time, I multiply that. So I'm plugging in y equals 2.75 times 1 hour. That's my x. So I just multiply that. 2.75 times 1 is 2.75. Then I'm going to plug in 2. So 2.75 times 2 hours. And I multiply that with my calculator in my head. And I get 5.5. And then I do the same with 3 and 4. 2.75 times 3. And I multiply that with my calculator, or I just figure it out. And I get 8.25, and then I do the same with 4, and I get 11. So there's how I got my table. So I have my table. We're going to find the slope of well A. Well, y2 minus y1 over x2 minus x1. So I picked 2 points on the table. I picked 5.5. Oh, I want to circle that. 5.5 minus 2.75 on the top, y2 minus y1, and then 2 minus 1 on the bottom, x2 minus x1. Did the math, and I got 2.75 over 1, and that is really 2.75. Pretty easy to figure that out without doing those calculations, because what I told you before is that is the slope of the line. So we could just use the equation. We don't even have to do that. I just wanted to prove to you that that's why it is. Okay. So that is Wells A rate. It does 2.75 barrels of oil for every 1 hour. Now well B, I have to find the slope of well B. So to do that, I have some points here. I don't know why I got those numbers written there. I wonder if I forgot to erase them. Yeah, I probably did. So anyways, I'm going to just use my rise over run. So I'm going to go till my stopping point here. I'm going to go from here to there, and then I'm going to rise. Right now, this is 4 units. How do I know that? Because 2, 4, 6, 8, 10. Every line is 2. So I go from 2, 4. Now this is going to go up by the same. 2, 4, 6, 8, 10, I believe. So let's put that in there. And that rise is 10. So the slope of that well B there is 10 over 4. Rise over run. Reduce it. That's 5 over 2. And in this case, we want to divide 5 by 2 so we can compare the decimals to a decimal. It's better than comparing a fraction to a decimal down here. So 2.5 barrels per hour. So what was the question? Which well pumped oil at a faster rate? Which one's faster? Is it well A, which is right here? Or is it well B, which is 2.5 barrels per hour? Exactly, it should be well A. So hopefully that answer will pop up. 2.75 is greater than 2.5, so well A's rate is faster. Shortcut, note that we already knew the slope of well A by looking at the coefficient in front of x in the equation. I already told you that. Oh, well, what's this one? Comparing an equation to a table, okay? Remember, we're comparing different things now. So now we've got the equation y equals 375x represents the relationship between x, the time that a plane flies in hours, remember time is independent, and y, the distance the plane flies in miles for plane A. The table to the right represents plane B. determine which plane is flying at a faster rate of speed. So we're going to call this plane B. And we already have plane A. Plane A here is shown as an equation. So we need to find the rate of speed. So use the equation to find the slope of plane A. Do you already know the slope of plane A? What is it? Yeah, it should be 375. It's the number in front of the x. That's your m, your slope. Y is equal to 375x. Y equals mx. M is your slope. That's easy peasy. Okay. Now we know that the plane goes 375 miles for every 1 hour. So that's its rate of speed. Now we have to figure out plane B. So we have to get the rate of speed. We have to find the slope for plane B. Use the table to find the slope. So you're going to pick 2 points. You're going to make one y2, y1, x2, and x1. When I'm doing this, I try to pick the smallest numbers. So I'm going to use this as my y2 and this is my y1, because why should I take great big huge numbers, right? If I don't have to, I don't need to. So just make sure that you pick 2 points here. I label them just so I don't get messed up. So y2 minus y1 over x2 minus x1. I did 850 minus 425 over 2 minus 1. Notice how I paired 850 here. Now my black bar showed up, but 850 over the 2 and 425 over the 1. Then I did the math, and I get 425 over 1, which is the same as 425 miles per hour. So which plane goes faster, A or B? Exactly, 425 is greater than 375. So plane B is flying at a faster rate. Oops. Okay, so now it's your turn to try some of these problems. All right, continuing on, we're on focus on higher order thinking. So a graph with a proportional relationship passes through the point 1, comma, 4.75. 4 and 75 hundredths. What is the slope of this graph? What is the unit rate? Well, with a proportional relationship, the y value when x equals 1 is the slope and also the unit rate. Therefore, the slope and unit rate are 4.75 for this graph. Couldn't get much easier than that, right? The general rule is 0.1 comma r, r being whatever number you put in for the proportional relationship here, means that r will always be the slope and the unit rate when there is a proportional relationship between x and y. So whenever you have 1, whatever the y value is at 1 for x, that is your slope and your unit rate for a proportional relationship. Next unit, we're going to be talking about non-proportional relationships. So this will only apply to proportional relationships. Where did my box go? Here it is. Okay, lost my annotate there for a minute. Okay, focus on higher order thinking again. 2 cars start at the same time and travel at different constant rates. That means they're going the same speed all the time. They don't slow down and speed up. Rate of change is constant anywhere on the graph. Car A's graph passes through the point 0.5 and 27.5. Graph B's or car B's graph passes through the point 4, 240. 2 different cars traveling at different but constant rates. Both cars show distance in miles and time in hours. How can you find which car is traveling faster with the given information? They just give you this. Can you figure out which one's going faster? Well, we already know it's constant rate, so we know we have a proportional relationship. What do we know about proportional relationships? What's another point we can know for sure? Well, proportional relationships always pass through the point 0, 0, right? So now we have 2 points, and if we have 2 points, we can easily find the slope because we have a y2 and a y1 and an x2 and an x1, right? So let's keep going. First, you find the slope for each car. Compare the slope for each car. The one with the greater rate is traveling faster. Clear that for a minute. And same thing. So car A's graph passes through that point, car B. Okay. Because both cars have a proportional relationship between distance and time, what I was just saying, we know that both their graphs go through the point 0, 0. Because any relationship that is proportional must go through the origin of 0, 0. A non-proportional relationship will not go through 0, 0. So the slope is equal to y2 minus y1 over x2 minus x1. Well, I've got a 0, 0 as one of my points. So car A is 27.5 minus 0 over 0.5 minus 0. So this is my y2 and this is my x2 because that was given to me in the problem. And then I used 0.00 for my y1 and my x1. Okay, and then I do the math. So I just get 27.5 over 0.5, right? And I divide that with my calculator and I get 55 miles per hour. So 27.5 divided by 0.5. So car A goes at 55 miles per hour. Why don't you pause the video and do car B and then check to see that you got it right. So car B, again, I'm going to use 4 and 240 and 0, 0. So 240 minus 0 over 4 minus 0 equals 240 over 4. I divide 240 by 4 and I get 60 miles per hour. So which car is going faster? Exactly, car B. Okay, the table shows the rate at which water is being pumped into a swimming pool. Use the unit rate and the amount of water pumped after 12 minutes to find how much water will have been pumped into the pool after 13.5 minutes. Let's bring up that table. There's our table. So time, at 2 minutes, the amount pumped in gallons is 36 gallons. Time 5 minutes, 90 gallons is pumped into the pool. At 7 minutes, 126 gallons is pumped into the pool. We have a big pool and it takes about 2 days to fill it up completely in the summer, just when you first open it. We have to drain half of the water out to put it, to winterize it. And then in the summer, we have to fill that half back up. And it takes a good 2 days with the hose running. Okay, this says 216, it got squished to the next line. All right, I diverse. Let's keep going. Step 1, find the unit rate slope from the table. How can we do that? Pick 2 points. My suggestion is pick these smaller numbered points. So y2 minus y1 over x2 minus x1. So I picked 90 and 36 and 5 and 2. Those were the smaller numbers. So then I do the math. 90 minus 36 is 54 and 5 minus 2 is 3. 54 thirds is then 18 gallons per minute. Okay, so now I know how many gallons every minute is pumped into the pool, 18 gallons. So what is the question asking us? Use that to find how much water is pumped into the pool after 13.5 minutes. Well, what can I do to figure that out? How about a nice equation? Let's write an equation for that. Y equals 18x, because 18 is our slope. So then I'm just going to go in and I'm going to plug 13.5 in for x right there and solve that. 13.5 times 18. So plug 13.5 into the equation for x and solve. We're seeing the wonderful uses of linear equations. So over here, I just moved 13.5 in that spot. Then I do 18 times, and I change 13.5 to an improper fraction. Remember how to do that? Whole number times the bottom plus the top. Clap, clap. Anyways, 13 times 2 is 26, plus 1 more is 27. 2 just stays my bottom number. So now I have 18 times 27 over 2. I could technically put this as 18 over 1 so that I can see that I have a fraction here. And I can cancel out the 18 and the 2 and put this as a 9 because 18 divided by 2 is 9 and 2 divided by itself is 1, right? I don't know if I had the computer doing that or not. So let's just see. Yes, I did. Okay, so we cancel out the 18 and the 2, we get 9 and we get 1. So we're just multiplying 9 times 27 on the top, and then it'll just be over 1. So 9 times 27 is 243. So the answer to the question is, after 13 and a half minutes, 243 gallons will be pumped into the pool. There it is. Okay, so that is the wonderful uses of linear equations. Definitely real world applications there. Okay, you get to try a real world problem. All right, we are done. So I will come back on. Here I am. And your lesson will be 3.3 on Google Classroom. And then next week, we'll be finishing up this module and going on to the harder stuff. So stick with me. You're doing a great job. And I love all the questions. And I love to see how much work you guys are getting done. And you're just doing a really, really, really good job. So have a good day or night whenever you're watching this. Bye.